Okay, so I wasn't originally planning to make another video on matrix multiplication, but I just thought there's a lot more matrix, like, things to cover on the multiplication bit, and the questions can get quite a lot harder than the ones that I showed in the last video, so I just thought I'd dive into those harder questions. And by the way, if you didn't watch the previous video, please do go and watch it, as it helps to understand the fundamentals of matrices. A is 5, 2, 3 minus 3. And B is minus 1, 0. Work out AB. We basically just do 5, 2, 3 minus 3 multiplied by minus 1, 0. Now with matrices, we don't usually write down the multiplication symbol. Now we remember how to do it, right? 5 by minus 1, minus 5. Plus 2 by 0, 0. 3 by minus 1, minus 3. Minus 3 by 0, 0. That gives us minus 5 and minus 3. All right. Work out 2AC. Now C is 0, 1, 3, 2. So 2AC, this is AB, right? 2AC. We have to multiply A by 2 first. So 2, scalar multiplication, right? 3 minus 3. That gives us 10, 4, 6, and minus 6. And we multiply this number by C, 0, 1, 3, 2. This is a 2 by 2 matrix, so 10 by 0 gives us 0, plus 4 by 3 gives us 12. 10 by 1 gives us 10, plus 4 by 2 gives us 8. 6 by 0 gives us 0, plus minus 6 by 3 gives us minus 18. So that becomes minus 18. 6 by 1 gives us 6, minus 6 by 2 gives us minus 12. If we simplify this, we get 12, 18, minus 18, and minus 6. All right, last one, work out C squared. We remember how to do squaring, right? We don't just do this. 0 squared, 1 squared, 9, 4. We can't just square each of the numbers inside. You have to expand it out and do it like so. 1, 3, 2. 0 by 0 gives us 0. Plus 1 by 3 gives us 3. 0 by 1 gives us 0. 1 by 2 gives us 2. 3 by 0 gives us 0. 2 by 3 gives us 9. 3 by 1 gives us 3. 2 by 2 gives us 4. Simplify. 3, 2, 9, 7. I think I made a slight mistake. 3 by 0, this should be a 6. 3, 2, 6, 7. This is why you should double check your answer. I did 3 times 0, giving us 0. But I should have done 2 times 3, giving us 6. Not 3 times 3. I think I did 3 times 3 by mistake. 3 times 1 gives us 3. 2 times 2 gives us 4. And simplify. 3, 2, 6, 7. Okay. Now this is when it starts to get a bit more challenging. By finding AC and CA, show that the matrix multiplication is not cumulative. Okay. So, we remember that AC from here. So A and C, 5, 2, 3 minus 3. I'll just write it down here again. A equals 5, 2, 3 minus 3. And C, 0, 1, 3, 2. Yes. Now, by finding out AC and CA, find AC and CA. Remember, I told you, the order for matrix multiplication matters, right? Show that it's not cumulative. Sorry, not cumulative, commutative. Now, what does commutative mean? It means giving the same result. Give same result. So we have to do it in different orders, A, C, and CA. We're still multiplying the same things, but in different orders, and we have to show that they do not give the same result. For example, in matrix multiplication, A times B does not give the same answer as B times A. Order for matrices matters. Order matters. We can't just do it in different orders just like with normal maths. All right, so we're going to do AC first. 5, 2, 3, minus 3, multiplied by 0, 1, 3, 2. That's AC. 5 by 0 gives us 0. 3 by 2 gives us 6. 5 by 1 gives us 5. 2 by 2 gives us 4. 3 by 0 gives us 0. Minus 3 by 3 gives us minus 9. 3 by 1 gives us 3. Minus 3 by 2 gives us minus 6. We simplify. 6, 9, minus 3. All right, now we do CA, different order, but same matrix. Will this give us the same answer? 2, 3, minus 3. If it gives us a different answer, it proves our point that the order matters for matrices. So let's find out. 0 by 5 gives us 0. 3 by 1 gives us 3. So already we can see that the answer is different. 0 by 2 gives us 0. 1 by minus 3 gives us minus 3. 3 by 5 gives us 15. 2 by 3 gives us 6. 3 by 2 is 6. 2 by minus 3 is minus 6. Simplify. 3 minus 3. 21 and 0. So what does it show us? AC is not equal to CA. Therefore, not commutative. All right, we'll just do one more. This one, it gets a little more confusing. We're gonna have square roots inside as well. So the question is root 3, 1, root 2, and 2, root 3, 0, and 1. All right. We do the same thing that we did before. Now, this might look a bit challenging, right? But we just basically do it as if we just do the same thing that we did above, just has some root symbols inside. So if we do that, 2 by root 3 gives us 2 root 3. 1 by 0 gives us 0. Root 3 by root 3 gives us 3. Remember, when you multiply the same roots, it cancels out and it just removes the root. Because root 3 by root 3 is root 9, and root 9 is 3. So that's their logic. All right, and 1 by 1 gives us 1. 1 by 2 gives us 2. Root 2 by 0 gives us 0. 1 by root 3 gives us root 3. Root 2 by root 2 gives us, root 2 by 1 gives us root 2. If we simplify, we get 2 root 3 plus 4 and 2 and root 3 plus root 2. Remember, we can't add roots with different numbers. And that is multiplying roots. I would have finished here, but I just want to do one more. Okay. This one is a lot more challenging. A 4, 1, 0, minus 2. Now we actually have unknowns in the matrix. And we have B and minus 3. And that equals minus 9 over 9. Okay, work out A and B. Find A and B. Okay, how are we going to do this? First of all, let's multiply this out and remove the multiplication. So A, scalar multiplication, right? So 4A, A, 0, and minus 2A. Multiplied by B over minus 3 is going to give us minus 9, 9. All right, we've got there so far. I think the best way to do this would be to multiply these out. Yeah, and just make it one big multiplication equaling this, and then we should be able to find out a and b. So if we do that, we're going to do 4a, 0 minus 2a multiplied by b over minus 3. So 4a times b, 4ab, minus 3a. And 0 times b gives us 0, plus 6a, minus and a minus makes a positive, right? Plus 6a. So that's going to give us 4ab minus 3a is equal to, not equal to, but below it's going to be 6a. All right. Now with that done, we can make it into a formula, right? 4ab minus 3a is equal to 6a. Not equal to, but you get the point. And this is equal to minus 9 and 9. Now we know how to do it. 6a equals 9. So a must be 9 divided by 6, which is 2 divided by 3. So it's 1.5 is a. A is 1.5. Okay, next bit. So previously we found out that a was 1.5, right? So then we just get this, we can ignore this bottom bit now, and we just look at the top bit to calculate b. 4ab minus 3a equals minus 9. That's a quite simple formula, right? And we just substitute a equals 1.5 into the formula. So 4 times 1.5, that gives us, if you put that into your calculator, that should give us 6. And then the b stays, minus 3 times 1.5, which would give us 4.5, I believe, if I am correct in recalling that. Yes. So that gives us 6b minus 4.5, and we just, 6b minus 4.5 equals minus 9. And if we just move the 4.5 over, that means that 6b equals minus 4.5, because minus 4.5 moves over here, right? So it becomes plus 4.5, and it was minus 4.5, so half of 9 is 4.5. All right, 6b is minus 4.5, and we just divide by 6. So minus 4.5, actually there's a simpler way. Don't divide by 6, actually. We can multiply this by 2. So that becomes 12b equals minus 9. Now, what does this get us? You can get rid of the decimals if you just do this. That means that b is going to be minus 9 over 12. And that simplifies. You can divide by 3, right? Minus 3 over 4, also known as 0.75. And that is b. So a is 1.5, b equals 0.75. Minus 0.75, by the way. Remember, don't forget the minus that was here. It needs to be minus. That is matrix multiplication. I hope this helped you. And if it did, please give it a thumbs up and subscribe if you want to see more videos like this. And in the next video, I do promise that I'll move into the identity matrix and share it with your friends if it helped. Thanks for watching. Stu Planed.